Hey guys, today we're going to check our number systems practice. So the first thing I want to go over is if you received a note to correct your graphic organizer, let's do that. So first, I want you to draw a big rectangle. So this entire rectangle represents the real number system. So up above it, write real numbers. And then I want you to split it right here. This is going to be your irrational numbers. And the big one on the left will be our rational numbers. So what we're going to do is we're going to make smaller and smaller rectangles. So now let's take right here, about halfway is what I'm going to do, and draw that. That's going to be our integers. Okay. Then I'm going to make one a little bit smaller. Oops, let me go back a little bit because we want to leave room for our numbers. Make one a little bit smaller, and that's going to be our whole numbers. And then make one a little bit smaller, even smaller than that, and that's going to be our natural numbers. And now we're going to go through and put our answers or our numbers from up here in our graphic organizer. So let's start with pi. And I'm going to, let's just do everything in black. That's fine. Pi we know is our most famous irrational number. The number 4, it's rational. It's an integer because it's a negative and positive whole number. It's a whole number, but guys, it is actually a natural number because remember, it's one of those counting numbers we learned as a toddler. 1, 2, 3, 4. So we'll put that in natural. -2. So first we want to decide rational or irrational. That's going to be rational. And then let's go down. Is it an integer? Yes, it's a negative whole number. So I'm going to put it there. I can't go down to whole because that's just 0, 1, 2, 3, 4. Just our positive whole numbers. Which brings me to the next number. 0 is rational. It is an integer, but the first time it shows up is as a whole number. So 0 should go in our whole number section. 2/3, rational or irrational? Well, it's rational because remember, all fractions are ratios, rational. Look at the square root of 25. What is the square root of 25? Well, it's a perfect square, that's 5. So it's rational, it's an integer, but it reduces to a positive whole number, so let's put that here. The first box that it could show up in is whole number. Now let's look at 2.3. That's just going to be rational because it terminates, it stops. It's a decimal that stops. Square root of 5. Is that rational or irrational? Well, square root of 5 is somewhere between the square root of 4 and, let's see, 3 times 3 is 9, square root of 9. It's not a perfect square, so it's going to be irrational. 7.32, that's a terminating decimal, so that's just going to be rational. 3/4, it won't reduce to a whole number, so it's just rational. -8, that is rational. Is it an integer? Yes. And we can't go down to whole because it's not a positive whole number. It's a negative whole number. So integers, -8, that's where that would go. Look at 2.55. This bar right here means it repeats. So that's going to be rational. Square root of 31. Is that a perfect square? No, the closest one is square root of 36 because 6 times 6 is 36. So square root of 31 is irrational. And let's look at 9. Rational or irrational? So it is rational. Is it an integer? Yes. Can it be a whole number? Yes. And it's a natural number because when we're little we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that goes in the 9 box.